O NEPED Entrevista de hoje está na Universidade de Aberdeen para conversar com o Prof.Charles Wang, professor do Departamento de Física e que assume os postos de Reader em Dinâmica e Cruikshank Lecturer em Astronomia. O professor Wang ministrou a disciplina de Ciências Espaciais e Sensoramento Remoto no final do ano de 2012, o que atraiu mais de uma centena de alunos interessados em temas como meteorologia do espaço. Além disso, ele coordena o Grupo de Gravitação Quântica e Teoria de Gauss, e é pioneiro na área de gravitação quântica. Então, professor, o que seria a gravitação quântica?
Yes, I lead a group carrying out advanced research into problems in quantum gravity, as well as developing new technology based on the quantum interaction of cold atoms and gravity, so that we may be able to apply to engineering areas, to do sensing, surveying, or even inspection tasks. Now, quantum gravity itself is actually a unified theory to bring two foundations of modern physics together, the quantum mechanics and gravitational theory described by Einstein's general relativity.
And you also are ahead of discovery of a particle, the gravitational particle.
Oh well, the particle still needs to be fully verified in the experiment. The process has already been started at CERN recently, but there are strong theoretical evidence that new particle that carries a new component of the gravitational field may be involved in what we call the cold collapse supernova process. What happens is that very heavy stars, at least 10 times heavier than our own sun, at the end of their main stage of life, friendly nuclear field converting hydrogen into heavier element up to iron. At the end of that process, nuclear field runs out, and the lower temperature induce lower pressure, so that the star can no longer support its own weight, and it started to collapse. As it collapses, it releases an enormous amount of energy, and this energy was thought to be the cause of the subsequent powerful explosion. But the detailed calculation shows that the gravitational energy described by general relativity being released isn't actually enough to explain why the explosion is so powerful. And my recent gravitational research suggests that the additional component would add to the gravitational energy available for the supernova explosion. And usually this component is not active unless you get really high energy, high gravity situation. And when that happens, this particle may be created, and they will transfer additional gravitational energy to a bursting star from its collapsing core. And that would explain why supernova explosions are so powerful.
According to NASA release in the NASA predictions in the last year, right now we are supposed to getting in the solar marking the peak of the solar activity.
Yes.
Which consequences if I have here?
Yes. The overall magnetic pole of the sun flip every 11 years. In the process called the solar cycle, and when that happens, the additional magnetic field will be induced in a turbulent way, and this would cause lots of energy to be fed into the corner as well as other high temperature particles around the sun. Because this process is so violent that the additional solar flare or the ejection of massive charged particles, plasma, and additional solar wind may hit the Earth, or in a better, more precise description, they would stir up the magnetic field around the Earth to cause some kind of magnetic storm. When that happens, this magnetic storm would in turn induce some unusual phenomena. For example, it would allow more charged particles to be guided towards the poles of the Earth, and make the usual northern light or northern light areas to enlarge. The magnetic disturbance due to a major solar event, which tend to be more frequent during the height of the solar activity around this year, would induce, for example, the pulse surge, and it would interrupt the telecommunications. It would also destabilize a navigation system. So anything electrical, electronic, wireless could be affected. Yeah. So it's important that we are aware of this, and also the industry can take countermeasure to protect the operations of these devices. Things like this can be very inconvenient, or it can be dangerous if you rely on navigation to the landing or takeoff operation, and suddenly it's corrupted. But learning from the past experience, the communications engineers have already made the devices more robust. And when it comes to digital communication, the corrupted data which may be caused by magnetic disturbance could work to some extent, so that the words you get in a not too fast situation is a slowed down speed, because the senders and receivers of digital signals have to spend more time to verify and to correct the data. Yeah. So hopefully, unless we really get a very extreme situation during this the height of the solar activity, we would expect some inconvenience rather than disasters.
Okay. Related to the risks of global warming, one of the lines of thought is the one that IPCC follows, which is that global warming might have been caused by human impact on climate. But there are some other factors that astrophysicists call the attention for temperature fluctuation, which could be caused by solar radiation, right? Why this second argument does not have so much visibility in the political opinion, and would it be important to have?
Yes, the solar activity would affect the global warming in such a way that if the sun becomes more active, it will send out more solar wind to set up a strong interplanetary magnetic field to shield the cosmic rays from coming into the solar system, and some of them would hit the Earth's atmosphere. So if we have less cosmic ray arriving at the atmosphere, there will be less cloud formation, and therefore more sunlight coming to warm up the Earth. So this indeed played a role of global warming, and depending on how the statistics as well as modeling is done, its contribution to global warming can be established. But I think there are some uncertainties as to what extent this contribution is, or perhaps some scientists will know better than others what the right contribution to the global warming due to the sun's activity should be. And I think this is an area that even astrophysicists are still disputing one another, and so it's not entirely clear whether the solar activity is more to blame for global warming or the carbon emission due to human activities. But the official figures, the official views of global warming tend to largely ignore the contributions from the solar activity. But one view would be that even if the global warming has a significant contribution from solar activity, you can control the sun.
Yeah.
And therefore, my personal view is that even the sun is to blame for global warming. We should still reduce carbon emission in order to offset this effect. So, of course, if carbon emission is indeed, as the official figure shows, the main cause, then obviously we must do it.
The last question, how do you see the future of physics?
Oh, the future of physics is very bright. The reason is that there are so many important issues that rely on physics, or good knowledge of physics to solve, like the shortage of energy. How do you find the alternative and clean, renewable energy? This cannot be achieved without knowing about the physics of energy, and the energy cycles, as well as all the physical processes in which energy is generated, and the impact of those processes on our environment. There are also some other aspects that physics is important. Security issue. How do you communicate more securely, and how do you identify potential risks through the communications, for example, that could be indication as to any security concerning issues. And then we have the blue sky aspect of physics, the more fundamental part of physics, such as new particles. Now, even with the completion of the standard model by observing the Higgs particle, physics is still largely incomplete, in the sense that the standard model itself does not explain the entire universe. Gravity is missed out in the description of the standard model, and gravity is the main theory to describe and explain the origin and the evolution of the universe. So how does gravity work with the standard model to complete the whole picture of the universe? It is still largely unknown. So we can expect that some experiment related to the evolution or even the origin of the universe could be could be designed and possibly carried out at CERN with increased energy. Now, at the very early stage of the universe, the energy level is far higher than what's been achieved at CERN. What's been achieved at CERN is still many order of magnitude smaller scale energy compared to the Big Bang scale, and therefore to actually simulate some earlier part of the universe, one needs to further increase the energy of particle collider. And even if the goal is not so ambitious as to trace the origin of the universe, there are some very attractive theories that could be verified by enhanced or upgraded facilities at CERN. For example, the string theory and the supersymmetric theory. Those are theories that bring about the hope to unify gravity with a standard model, and to observe their predictions. Much increased energy scale will be required for the particle collider, and therefore there's, I would say, that the future of physics is still very bright, and there are still a lot of fascinating works to be done.